Hi, I'm Raquel Villanueva with the news team here at NASA's Jet Propulsion Laboratory in Pasadena, California. Now, right now, there is an exciting project happening right here that could one day help astronauts breathe on another planet as we get ready to go back to the moon and eventually Mars. So that's why I'm here with Asad Abu Baker. He is the system engineer for an experiment called MOXIE. Now, MOXIE is going to be on the next Mars rover, and it's going to help create, or it's going to try to create, oxygen on Mars.
That's right.
So I have plenty of questions. If you have questions, please put them in the comments, starting right now. So first off, tell us where we are.
We are in the JPL ISRU Development Lab, and ISRU is an acronym that stands for In Situ Resource Utilization, and that means being able to use the resources available to you at the location that you're going to, rather than having to bring all of the raw materials with you yourself. So it makes it so that you don't have to launch as much stuff. You can just go and live off the land, so to speak.
So what exactly is MOXIE?
MOXIE is an oxygen plant, and MOXIE stands for the Mars Oxygen ISRU Experiment. And so what we're doing is we're demonstrating technologies that would be used to generate oxygen on the surface of Mars on the next Mars rover mission.
So you were saying it was an acronym before.
Yes, yeah.
So is it like an acronym in
It's
an acronym?
actually an
Is that
acronym
how I
within an
got it?
acronym. We've got that ISRU in the middle of the MOXIE acronym, which is a little recursive for those fans of recursion out there.
Okay, that is a lot to remember. I'm very impressed. So can you explain to us how MOXIE works?
Sure. Yeah, MOXIE basically has inside it a pump that draws in gas. This is the inlet tube, draws in gas here. It goes inside, and we can take a look inside our model a little bit later, into the pump, which compresses it and delivers it to our electrolysis system. The electrolysis system operates at 800 degrees Celsius, and it is responsible for doing the electrochemistry, which reacts the CO2 with a catalyst and generates oxygen and separates it out from the CO2 gas stream, and then runs it through some sensors and dumps it outside the rover.
So last time I saw it, it was in this kind of bell jar glass dome.
That's right.
What is that for?
That is because Mars has a very different atmosphere than Earth, so we can't simulate the operation of Mars effectively in an Earth's atmosphere environment, so we put a glass bell jar on here to make it a vacuum system so that we can put in a Mars-like atmosphere that's about 1/100th the density of Earth's and mostly CO2.
And the second thing I noticed was all the bling. Is that actual gold?
It is in fact actually gold. Gold is a very efficient reflector of infrared heat, and because we have this very hot electrolysis system inside, we wanted to make sure that we didn't radiate heat onto any of the other things around us within the rover, and so we plated it gold to make sure that we didn't cause any negative effects on anything around us.
So how hot does it get?
The inside gets to 800 degrees Celsius, and that's where the electrochemistry happens, but we have a really good insulation system around that so that the outside doesn't get very hot.
And I heard before you might be running some tests on that. Is
Yeah,
this what you're doing right now?
That's right. Today we've been just running some additional tests just to make sure we understand completely how we're going to operate the instrument on Mars.
And it makes cool sounds when it does that
It does make
too?
cool sounds, although it's a little annoying, so we're not going to run it right
Today.
now.
And I also want to know what it looks like on the inside.
Well, if you can come over here, we have a model that shows what the different parts inside look like. So this is basically the same as that in a plastic 3D printed version. So this big chunk here, that's this, it would go here. This is where all the electronics live. This is that pump that I mentioned earlier. So the inlet gas comes in here, goes into this pump, and then it gets delivered to this box here, which is the electrolysis system. And inside this box is a bunch of insulation to keep all the heat in, and an electrolysis stack that looks very much like this. And so this is really the heart of MOXIE right here.
Is it lightweight? Can I
No,
touch
it's
it?
not. It's actually
Oh,
quite dense. It's
can I
very,
see?
yeah,
Okay.
you can go ahead and pick it up.
Oh, wow.
Yeah.
I did not expect it to be this heavy because
Yeah.
it looks light when you first see it.
Right.
So
Well, I'm very strong, so, you know.
That too. How much oxygen is this making right now?
None. But on Mars,
Very smart.
it will be generating about 6 grams an hour of oxygen.
Okay, and how much is that? Can humans survive on that?
No, 6 grams an hour could probably keep a small dog alive. If you wanted to keep a sleeping human alive, it would probably be closer to 20 grams an hour of oxygen. And if you wanted to run a larger scale system that could, do multiple humans, it would have to be scaled up quite a bit.
So short-term plans, it's going to be on the rover.
Correct.
So where is this going to live?
This sits inside the belly of the rover, so in some ways it's a little isolated from the environment around us on Mars, but it does have an inlet filter that sits on the outside, so that's where we draw the gas in from. So, I mean, if I were a Mars rover, it'd probably be somewhere around my liver.
Okay, kind of live in there.
Somewhere.
And then...
I don't know exactly. I'm not a doctor. I'm not that kind of doctor.
And then long-term goals for it, would it have to be a lot bigger than this to work for humans?
Absolutely. Yeah, we would need basically something that's scaled up from this by about a factor of 200 to make a useful system for future human exploration of Mars. That's not just to generate oxygen for humans breathing, but we don't just want to send people to Mars, we also want to get them back. And one of the most important elements of getting people back from Mars is being able to get a rocket off the surface, and oxygen is a very important component of rocket fuel. And so a scaled up version of MOXIE would generate also the oxidizer for use in the rockets to get off of the surface of Mars.
Why is it easier to make oxygen on Mars rather than just bring it up?
It really comes down to mass. We could, just based on what we've learned already from MOXIE, scaling up MOXIE to a full human exploration scale would weigh about a ton. Whereas if we wanted to bring all that oxygen with us from Earth, we'd have to launch something like 200,000 tons of oxygen from Earth.
Very heavy ship.
It's very heavy.
It's probably the same as this.
Yeah, that's right.
And then I'd also want to know, does this have a practical application one day on Earth, or could it one be?
It might. Not specifically in the way it's done on MOXIE, but the technology can be used in a number of ways. It's very flexible. Because the only thing we know we have available is CO2 on Mars. But on Earth, we have other things available like water, and if you run water and CO2 through this sort of electrolysis system, you can generate things that are precursors for useful things like fuels or plastics or things like that. And so something like this might end up reducing our dependence on fossil fuels.
So MOXIE has a lot of potential right now.
Absolutely.
What does it need to succeed on Mars? What needs to happen?
We need to get there, and we need some electricity, and then we're good to go.
And are there any questions out here?
Absolutely, yes. On the topic of electricity, they want to know how much power does it use?
That is a great question. When we're at full tilt generating oxygen, it takes about 260 watts of electrical power. And so we generate oxygen for about 2 hours potentially, and at that time, by that point, we basically drain the rover's batteries, so they have to stop and they got to recharge.
So we're also getting asked, could technology like this be used to reduce CO2 in Earth's atmosphere?
It depends on how you generate the electricity to run it. So if, for example, if you're using fossil fuels to generate the electricity to react with CO2, then it doesn't help. But if you have solar or wind, then yes, you could. But then one of the outputs of this process is carbon monoxide. So then you have to figure out what are you going to do with the waste product, which is carbon monoxide. It's industrially useful, but there's probably, if we were using this on an Earth scale, it might have more carbon monoxide than we know what to do with.
Right, and we've also had a lot of people express interest in working at JPL and NASA. How did you get where you are today?
Oh, that's a great question. Well, I have, I should say that I studied really hard, but I did.
Don't hold back.
Yeah.
Be the inspiration they need.
Well, no, I have a PhD in physics, and
that sounds like studying hard.
Yeah, it was at times, and I've always been interested in space, and I just happened to be able to get in contact with some people here that were looking for people to work on interesting problems, and it just worked out.
I kind of want to know, what's the most exciting part about working on MOXIE?
Being able to send something to Mars is amazing. I know people at JPL do that all the time. This is like old hat. People send stuff to Mars here at JPL. For me, this is very new, so it's very exciting for me. And also being able to do something that's really never been done before. That is really an exciting opportunity for me personally.
That's great. Well, let's just leave it on one last side of MOXIE. If you want to see more behind the scenes footage like this and talk to Assad again because he's super cool, please follow all our social media channels at NASA-JPL. And once again, I bring you MOXIE.